error in a science experiment. Basically what you're doing is you're saying, okay, these were my estimated values or my measured values that we actually did with the experiment. Subtract away from it what I should expect to get out. Maybe theoretically this is what I should get. Or these are some actual values that we should try to be modeling with this experiment. And then we divide that by our actual values, and we multiply it by 100, gives us percent. Okay? We like to take the absolute value of that percent, but that's what it tells us. Basically, that percentage then tells me how close my scientific experiment was to the actual thing. Does that make sense? Okay? The smaller the error, the better your experiment was. And what we mean by that is, you know, with experiments, we want things to be controlled, right? We want things to be precise. We want things to be accurate, okay? The greater the error, the less precision, accuracy, the more human error that takes place, and that kind of stuff, right? Okay? If I can minimize that, then that basically means that my tools that I used to do the experiment were precise, okay? And the procedures that I went through generated accurate values. With handheld compasses and rulers and straight edges, there's usually a lot of imprecision with the tools. Somebody has a $30 compass, okay, it's going to eliminate a lot of precision, okay? Or sorry, it's going to eliminate a lot of imprecision. They're going to be very precise. So this is a compass. This compass probably costs about $15. But it's got gears and all that kind of stuff in it, and it's very precise, okay? There's a piece of lead here, a piece of graphite, and it's like a, as you remember back in like second grade, third grade, you had those really fat pencils. It's kind of like the lead in one of those really fat pencils, and when you write with fat pencils, it just kind of looks, it's real thick and childish looking, right? Well, that, in terms of construction, is imprecise. So if we want to be real precise, what we would all have to do is have like a piece of sandpaper. And so when I was in school, this is what we did. We had sandpaper, and we had to sharpen our pieces of lead on that sandpaper to make our constructions more precise, okay? We had to have, under every piece of paper that we worked on, we had to have like a thick piece of cardboard so that if I put my needle and my compass on my desk, it wouldn't slide around on my desk, okay? So there's a lot of things that create imprecision if we're actually using a compass in the classroom. What this does, because it's digital, eliminates a lot of that human error. There is still a couple places that there's going to be human error, but for the most part, we should be able to eliminate the imprecision, okay? So just kind of mess around with this a little bit. What we've got here, I'll kind of go through these tools with you. This one here is just going to be able to change the width of your segments and arcs that we use here, that we create. The idea is that we really want the most precise, the thinnest line possible. Okay? So if I were you, and I was doing these constructions on my personal computer in front of me, because you got good kind of proximity to your computer, is use the smallest kind of setting there. On my computer, since it's far away from you, I think usually that smaller one kind of messes with people's eyes sometimes. So I'm going to use a little bit of a thicker one, and that's going to create a little bit more imprecision for me than it does for you. Not a big deal, though. Okay? You can change the colors of your lines. Okay, we'll do that. We'll use the colors. You got to change the color before you draw the line. This, I think some of you are finding out. That's your pen. Okay, you can draw. It's kind of blocky, not really smooth, but you can draw on that if you need to. I'm going to skip over the next one. Clear button down here will clear everything. Okay, so that just wipes everything away, gives you a blank new starting point. If you do something that you didn't like, okay, the back button will undo every previous thing. We got a protractor here. Okay, really the benefit of the protractor is just as a check to some other things that we're going to do, some of the constructions that we're going to do. We can rotate that protractor. We can get the numbers to go away, disappear. I think that's it. I don't think there's any other hidden kind of components that. To get this to go away, though, you got to click back on that box. Okay, clear doesn't get it to go away. The back button doesn't get it to go away. You got to click on that box to get it to go away. Ruler, same thing. Okay, move that ruler around. Ruler's kind of a pain in the butt. Click the arrow, it's just going to flip the numbers to the other side. The way we're going to use this, we just want to use it as a straight edge. So I really kind of want to focus on using this non-graduated side. But you notice as I move my marker over here, my cursor, it turns into a marker, right? If I click and drag, it will act like I'm writing along that ruler on my desk. Does that make sense? Okay, we'll use that one time today, and then probably use a different tool to get that line in other situations. Again, to get that ruler to go away, I click that tab there, and then we'll clear that out. Okay, so those are our tools. They're not all that difficult to use and manipulate. The one tool that's the most important is our compass. Okay, and again, there's some hidden features here in the compass that we have to be able to understand. I should be able to grab, so every time that I move my cursor on top of my compass, and I can do something, it's going to turn into that little hand icon. Okay, if I grab the needle, it allows me to move my compass around. Does that make sense? Okay. If I grab the pen and I move my compass, I'm clicking and holding right now, it allows me to change the width of my compass. Okay. If I click this lock, it's actually going to, now I click the pen, and I'm moving back and forth, but it's not opening and closing the compass anymore, right? I've locked it. That's going to be something that we need to be able to use. Okay? Some people neglect it, and then they try to move the compass, and then they accidentally move this as well, and now we've got a problem because I changed the size of my compass. So every time that we move our compass, we're going to want to lock it before we move it. When you come up here to the top of the compass, this tab up here, knob up here, when you click on it and move your cursor, it's then going to start drawing for us. And draws that circle. That's pretty much what we're going to use. Does that make sense? Can we do that? Okay, like I said, when you get to a point, you got a little bit of free time, I'm going to ask you to do some homework questions in the next couple of days with this stuff. Kind of mess around with it a little bit. Okay? The one thing that kind of stinks with this, and it's inevitable, we're going to run into this. Try to minimize as much for you guys as I can. It happens a lot in fourth period, or sorry, what's the last period? Sixth period. We're going to kind of copy this line here a little bit. Well, when I put it all the way up there, now my compass disappeared, right? And I can't get up here. So we're kind of confined by the size of our screen here. So when we're trying to kind of mimic the things that I do in class, try to position the things that I do on the screen up there the same for you on your screen. Does that make sense? Try to make them the same size. They're not going to be exactly the same size, but relatively try to do the same thing I'm doing. Okay, try to mimic my screen with yours. Is that okay? And that will eliminate any of those issues where our compass is off the screen and we have problems. All right. So first thing I want to do, guys, is we're going to be provided a segment. So I'm just going to take that segment right there. So I want you to grab your line tool and draw a segment kind of like that. This first construction is one of the most simplistic constructions we'll ever do, but it ends up being kind of the foundation for all of our other constructions. Okay, it exists inside all of our other constructions, and it's just copying a line. It's developed given a segment. Can you make one that is congruent to it? Okay. Sometimes we refer to it as transferring a distance. Okay. You guys ever watched like Pirates of the Caribbean type movies? You got pirates, you got a nautical type thing. Even when I say nautical, that's lean or air and sea, right? Okay. You ever seen somebody on a map? Okay, maybe some war movies they do this. They've got a map and they've got one of these things. Okay, and they do they kind of walk around that map like this, right? Does that make sense? You seen that in a movie? You know what they're doing? Yeah, what the map always have on it that tells me distance. It's got a key on it, doesn't it? Okay, got a legend. And I can go over here and I can figure out what that distance is. Maybe my legend or my key says that length right there is maybe 10 miles. And then when I've got points on my map, I go from there. So that was one 10-mile interval. That's another one. That's another one. That's another one. Does that kind of make sense? I can track how many multiples of 10 miles that I'm tracing out. Okay. All that is I've captured a distance on my compass. Okay. Now this isn't. We don't call this one thing here a compass, but I've captured a distance, and that's all our compass does. It captures the distance between our needle and our lead of our marker, okay, or pen, whatever you want to call it. So we're going to use that idea to help us create a congruent segment. So I want you to come over. I want you to use a different color. I'm going to use a red. Doesn't matter what you use. But I'm going to draw a segment then that I know to be longer than the black one. Okay? If it's shorter than the black one, I'm going to have a problem. Basically, what we're going to do is we're going to see how long the black one is, get that distance on our compass, and then mimic that on the red one. Well, if the red one's not as long as the black one, there's no way that I'm going to be able to do that. Okay? So here's the steps for this. Okay? You're going to take your compass and put your needle on one endpoint. And the nice thing about this is that as you're doing this, it will snap that needle to that endpoint. So there's really no guessing on whether your needle is on that endpoint or not. Okay? It will automatically kind of pull that needle to it. Okay? The next thing you're going to do is you're going to extend your compass so that your marker goes through the other endpoint. Okay? Once I have that, I'm going to lock my compass. Lock my compass. So now, no matter where I move my compass on the screen, the distance between my needle and the marker is going to be that black distance. Does that make sense? Okay. Now, what we're going to do next is just kind of a check. This is what you would do if you have the compass in front of you and paper in front of you and all that kind of stuff. You would, just to check to make sure that you've got the right distance on your compass, you kind of spin your compass just a little bit and make that arc. If that arc passes through the end point of my segment, then I know that I've got the length of that segment on my compass. Okay? At the end of the year, when you take the end of course exam, they're going to ask you questions like this. They're going to ask you, basically they'll lay out the steps of some construction and ask you, what do you do next? Okay? Or they might give you like 6 or 7 steps and ask you to put them in order. Okay? Or they might say, this student did these 10 steps for construction. What did they do wrong? Okay? They won't ask you to mimic a construction. They'll ask you what's next, what's wrong, that kind of thing with a series of steps. Okay? But my argument is if we can do it ourselves, we can do the construction ourselves, then we can figure out what is going wrong when somebody else does it. The reason I say that is that they're going to give you like a series of 3 or 4 pictures in those problems, and they're going to have little arcs here. Right? I just want you to know what those arcs are, what they mean, that kind of thing. Okay, so now that we've got that distance, no matter where I move my compass, I've got that distance on my compass, right? Well, I'm going to move my compass so my needle is on the end of that red segment that I drew earlier. And now I'm going to draw an arc that passes through this red segment, just like this arc right here. And then I'll move my compass away. And the hope is that we realize, now it's kind of, I don't want you to draw this on there because, again, their drawing tools for their pen isn't very good. But if this is point A, I would call that like A prime. Does that make sense? So those 2 points correspond to each other. If this is B, that would be B prime. I don't know why it won't let me put that prime mark. But those 2 points would correspond to each other. Does that make sense? So that distance there is the same as that distance there. And that's just by capturing that distance on my compass. Okay? All right. So let's go. Let's clear that. And let's grab our segment tool. Let's change some colors. Let's make one of our segments. We'll actually do it this way. Give yourself a little bit more room than what I just did. Come down here to maybe about right there. Make a blue segment. We'll make a red segment. I'm just going to make my red segment different than my blue. Okay, I'll make mine a little bit longer. And then I'm going to make a green segment. And again, I'll make my green segment different than both those. So I'll make my green one smaller. Pushed the wrong button. Sorry. What I had? Blue. What was the first one I had? Blue. Blue. Red. And green. The only thing that we got to pay attention to here, guys, that when we're setting this up, I don't make one that will exceed kind of my compass. Does that make sense? So if I stretch my compass all the way out and I had a blue one that was maybe that big, there's no way that my compass can replicate that blue one. Okay? Now, there are ways we could chunk that up into pieces and then do it. Okay? But the idea is to initially try to make these given segments here smaller than your compass's overall length. Okay. I'm going to call this segment B. And again, you guys don't have to write this on there. We'll call this one R. And let's call this one G. Okay? And if I ask you, can you take B plus R plus G? Can you find a segment that would look like B plus R plus G? Did you guys agree that's segment addition? Take segment B, add to it segment R, add to it segment G. Okay. Kind of visualize taking the blue one, putting it tip to tip with the red one, and then putting the green one tip to tip with that one. Kind of visualize how big that would be. Okay, for your particular picture. What I want you to do then is create a segment. I'll just do this black. We'll make a segment that I know is going to be at least as big, hopefully longer, than what I think B plus R plus G will look like. Okay? If I make it shorter, we won't get intersection points that we're looking for. Okay? So make that segment. And now what we're going to do is we're going to go up there, we're going to capture distance B on our compass. So I'll do this, and I'm going to try to keep the colors consistent here. So I'm going to take my compass, I'll go up to B. Okay? I'm going to lock my compass. And this is the part that kind of stinks. Don't worry about that. I'll undo that. I want to be able to draw that arc, right? But when all the way up there, it's kind of hard, but there we go. So draw that arc. Is that okay? Now, if you can't physically draw that arc right now, that's fine. As long as you know on your compass it snaps there, you've got that distance B, right? Okay? Lock my compass. Come down here to my black line. Draw that arc. Would you guys agree that that distance right there is that blue distance? Okay? I want to add to that the red distance. Add to it the red distance. So I'm going to take my compass up here, put my needle on the end point of the red, unlock my compass so I can stretch it, put the pen on the other end point, lock it, kind of draw that arc, I know I've got distance R on my compass now. Okay. If I come down here and draw that arc, don't do this. If I draw that arc, is anything up there than B plus R? Or do I have B and R kind of overlapping each other? That makes sense? They're overlapping, right? I don't want them overlapping. I want them end to end. So instead of going from there, I'm going to take my compass and I'm going to go to there. Because now that just put, when I draw this arc there, it put the blue line B and the red line R, they're sharing now an endpoint. So they're collinear, they're end to end. Okay? Now if I wanted to add G or any other segment to it, I just keep doing that process, right? Okay? So I'm going to go grab the green one. Draw that arc. And I'll come down to the last arc that I made here on my new line. And I will draw that arc through. Move that away. And now from this blue point here up to this green arc, that would be the segment B plus R plus G. Does that make sense? Okay. What if I wanted to go B plus R minus G? B plus R minus G. Go minus G. I've already got B plus R, right? I've already got G on my compass. If I put G right there, if I mark G right there, that'd be adding it, right? What if I come over, come on, this way, and I mark on that side? Does that make sense? So this would be B plus R gets me to the red, and then backtrack G would put me right there, right? So that would be my final endpoint of B plus R minus G. So this, I'll just do it in purple here, with a real thick line. That distance, that's really not all that thick, that distance there would be B plus R minus G. Is that okay with everybody? Just kind of work backwards in that subtractive idea. Okay? So that's copying a segment length and then doing a little bit of segment addition. Okay? I want you now, we're kind of going through kind of progressive in regards to how we've attacked these shapes in this class so far. We started with points, went to segments, then we got to angles, right? Let's deal with angles here. I'm going to take down here, I'm going to create, and it doesn't have to be that line. This line doesn't have to be horizontal or anything. That's just usually the way you see it. I'm going to draw that angle. Okay, so draw something similar like that. And that's going to be what we call our given angle. That's the one that we're going to try to copy. Somebody would give that to us, provide us with that, and then they'll say, okay, now that we have that angle, can you make a replica of that? Can you make an angle congruent to it? Okay. So the first step, very similar to the other ones that we've done. Okay, I'm going to try to copy this in, I'll do it in red. But basically all we have to do is make a segment that is kind of like that one. So if I were to, and again, you don't have to write these down here. Let's say we called this A, and there's some maybe point here. Let's call that B. Then this would be A prime, and over here, that would be B prime. Is that okay? So that point right there corresponds to that one. This one corresponds to that one. Okay? So we have to mimic one of these lines. Okay? The idea is that this red line, just don't make it smaller than this one. Okay, 'cause it won't always mess things up, but sometimes it will. The next thing you're going to do, let me see if I can get this compass flipped around. There we go. All right, so I got my compass. Did that last period of same construction. Pushed the wrong button, so sorry. All right. Next thing you're going to do is you're going to take your compass, and you're going to move it down. The needle is on that vertex of the given angle. The needle is on the vertex of the given angle. You're going to stretch your compass out. Okay, the idea here, guys, you can actually take your compass, and it can be like that big. Now, that's going to be stupid to do that, and I'll kind of talk about this in a moment. But I'm going to stretch it out a little bit, give myself some room, okay? Think about this. If you guys have ever, measured, maybe to cut a 2x4, not 2x4, a panel of 4x8 OSB or drywall or something like that. Let's say I've got this rectangular 4 foot by 8 foot board that I want to cut. Okay, and I want to cut it down to 4 by 6. So I want to make take my tape measure from here and I go down 6 feet and I make a mark right there. Does that make sense? Okay. Well, if I come here, take my tape measure and go down 6 more feet. These 2 points are very close to one another, right? Because they're very close to one another, when I put my straight edge on them, okay, I might kind of drift. My straight edge might drift to where when I come down here, that distance there is maybe 6 feet and an inch. Does that make sense? Okay, because over that remaining kind of 4 feet, that is left between my other side of that board, we accrue quite a bit of distance. Okay, that is all. Okay, a lot of error. Okay, so what I do is instead of marking here at 6 feet, and then right next to it 6 feet, I'll come down here and measure 6 feet there. Does that make sense? And now I can connect my straight edge from that point to that point. And what a lot of people will do, just to be safe, just to be sure about things, they'll come halfway in the middle, and they'll mark 6 feet as well, right? When they line that one up and that one up, it should go through that one as well. And then they can cut on that and be guaranteed that this is now 4 by 6 instead of 4 by 8. Same idea, so that's eliminating the imprecision of human error, okay? When we do that in a construction, it's the same idea, okay? I want to give myself a little bit of room. I don't want to be really tight here on this vertex. So give myself a little bit of room. And I'm going to lock my compass. And then we'll draw an arc that is going to pass through both of my rays of my angle. Okay. When I do that, does my arc create intersection points? And 2 intersection points, right? With my segments. We're going to try to mimic those. We're going to try to figure out how we can find those intersection points. So I'll come over here. Compass is locked. Don't change the distance. And I'm going to go there. Remember, this point here, I call that A. That matches up to this point here, I call A prime, right? I'm going to draw the same arc. Okay? Now, when I say I'm going to draw the same arc, basically what I'm doing, if I were to continue that arc all the way through, I create a circle, right? So whenever I say arc, I'm only talking about the circle that it comes from. I want to draw the same circle. The same arc would mean I drew the exact same size of the first arc, and I'm not going to be able to do that, okay? But I want to draw the same circle, and I want to make it at least as big as what I've done here, okay? If I were to just make my arc like that, okay, the next couple steps, okay, so this point here is going to correspond to that point there. Does that make sense? Okay? Well, if I don't make this arc go big enough, I'm not going to be able to mimic that point. I'm not going to be able to find that one. Okay? So that's why we've got to have this arc here at least as big as this first one. And I think I've probably got that. Okay? So, just so I can talk about these points a little bit, let's go back and name these. We have that as A prime. Let's call this C. And we'll call this C prime. Okay. So C and C prime match up. Would you guys agree that I could call this a point? I could call that point D up there? So would you guys agree then that D prime has got to be somewhere on this curve? I've got to be able to figure out where it's at on that curve. So what we're going to do, we'll take our compass, I'm going to do it in blue here, and I'll put my needle on C. Put my needle on C. And I'm going to rotate my compass so that I can unlock it, get my compass to have my marker go through D. So my needle's on C and my marker's on D. And what this is effectively doing is it's gaining that span between our two rays of our angle. Okay? And I'm going to lock my compass. I'm going to draw a little arc right through there. Okay? So what I just did there, I'm going to come over to C prime and do the same thing. Draw that little blue arc. Okay? Does that create then that point right there that I can call D prime? Okay? Now this is where we would need a straight edge. Okay? Now the tool that I'm going to show you to use, so I'm just going to mimic how you would do this on paper and pencil. Click on my ruler. This is what kind of stinks about this ruler. I don't know if there's any programming that would be better than this. Like if I line up A prime, now I got to kind of swing this into my ruler, right? So I line up A prime, and now I got to swing this into my ruler but to go through D prime, but what happens then? My ruler's not going through A anymore, right? Or A prime. So I got to kind of go back and forth with that process. It's a pain in the butt, okay? So if you want to do that, that's fine. If you want to mess around with doing that and getting those things to line up, you can. And then once you do that, move your cursor right above the ruler. It will turn it into a pen, and then you can trace it, okay? Here's my argument, though, doing that way. If I were to zoom in right there on my cursor, I think I missed actually D prime. I don't think I really go through D prime. Does that make sense? And if I zoom in down there on A prime, I don't think I touched A prime. I'm not going to use that tool very often. What I'm going to do, well, backtrack that, get rid of my ruler. I've got this segment tool, right? Let's use the segment tool. Now I can better click on A prime. And can I make sure that I go through D prime? And actually, like, snaps to D prime. Okay? And then what's nice, if I want that to go further, I can actually come back down to A prime. And now just make it go further and just make sure that this second line here that I'm making actually traces over that first line. Does that make sense? And that then is duplicating. It's creating a congruent angle to the one that we were given. All right. Is that okay with everybody? Now let's see if that is actually true. Let's verify that. Let's take our you guys don't have to do this. Just kind of watch. That's the only reason that this program has this protractor on it. And we'll just use the protractor kind of the easiest way. We'll line it up like that. And we see here that this I made kind of a 45-degree. If I'm tracing this line here, this ray, it's going through a 45, right? You maybe see right here it'd be going through 135, but the acute angle of 135 is 45. Okay, so that's 35 degrees. So what should this angle over here be? Or sorry, 45 degrees. So what should this angle here be? Should be the same thing, right? Let's see if it is. Kind of make sure. I don't know if I can get rid of. Really see if it's, there we go. Is it going through 45?
pretty close, right? Okay, you might say, well, it's 44 or 46, because this is not necessarily going through 135 there. But it's close. The only reason that it's not exact is the human error that I contributed. Does that make sense? Okay. If we were to do this on paper and pencil, some people would have like 45-degree angles when they started, and when they completed it and they were done and took the protractor and put it over the congruent one, they'd have like 50-degree angles. Okay, and that 5-degree error is a huge difference. Okay, so this hopefully minimizes that. I want to do one more with you. One more. This is an easy one. This is one we're going to use a lot. Take a segment, make it at least, so if I know what my compass looks like, the length of my compass, basically what I want to do right now, and I don't know why, there we go, grab my compass. I just want to make this segment less than twice as big as my compass. So if I had my compass stretched out all the way, I want that segment to be smaller than twice that distance. Okay? So something like that I've got is probably fine. I want you to take your compass and put it on one of your endpoints. Doesn't matter which one. I'm just going to go on the right one here. And I want you to extend your compass. Would you agree that maybe my midpoint is right there where my marker is passing through? Make your compass go beyond that point. Make it bigger than half of your segment. Okay? Make it bigger than half my segment. Lock my compass. I'm going to rotate my compass. Okay? And I'm actually going to do this. I don't think it's going to be, I made it too big. You might see the same thing on yours in a moment, but we'll see. I'm going to rotate. Okay, so cool. Go to the other side, the other endpoint. Now this is when I got my compass locked, right? So I still got that distance right there on my compass. I'm going to rotate my compass. And we'll draw that arc right there. Okay? I think when I first made that bigger arc here, I think this point here, which is going to be a point we need, would have been down here, and you wouldn't have been able to see it. Okay? Anybody's point kind of come off the page and not intersect down here? So all you've got to do if that's the case is just readjust your compass size here. I'll do it maybe in red here. And kind of do the same process. Go from those to those. So nobody's going to have double one of these, but it doesn't matter the size that you choose. So here's the idea. If we just look at the black ones that I chose, that I made, is that a point right there? My cursor is? Is that a point right there? How many points do you need to make a line? 2. So if I click on that point right there, and this black one right there, now here's the idea. It also went through the red ones, right? So that maybe shows you that you don't need the same distances that I chose, okay? But what happens here is we get that. That point right there, does anybody want to guess what that point right there is, where my cursor is, of the segment that I started with? It's the midpoint, okay? So we just found a midpoint. Now, think about that black line and that blue line. What if I put this guy on top right there? Let's make it a little bit smaller. What kind of angle do I have right here with the black line and the blue line? A right angle. So that blue line, or that blue segment, is called it's a right angle. It's perpendicular, right? Goes through the midpoint, so it's a perpendicular bisector, correct? Does that make sense? Okay. So that structure there is finding a perpendicular bisector. Now, here's the idea. This is what I like about GeoGebra, is that we can do this with GeoGebra pretty easily.
Okay, we start with a segment. Okay, now we put arcs on, but really what we did is we made circles. So I'm going to make a circle that is like bigger than half that segment. So I make a circle with 4. And come here and make a circle with 4. You see how those circles intersect? So that point up there and that point down there are the 2 points that you found, okay, where yours intersected. Here's the reason why I need to choose circles at the beginning that were bigger than half. Well, I had to make my compass bigger than half at the beginning. If it's not bigger than half, what happens? Circles don't intersect. I don't get those intersection points, right?
Just a reminder to wear your Halloween gear tomorrow if you want to receive Halloween candy from Student Council.